couple of weeks ago I did my first video on Rust game development where I'm building a 2D top-down MMO style simple game. If you haven't seen that video, you might want to check that out first because it will use concepts that I went over in that video. This video will talk about concepts that I outlined in that video, and I might do a quick refresher on a couple of things, but that one will give a more in-depth outline. So in this video, I'm going to talk about monster and AI, or monster and NPC instantiation into a game. So originally I wanted to do AI and monsters and everything all in one video, but then I realized that to give a good outline of that, it would kind of be like 40 minutes, and I'd rather do two 20-minute videos or maybe two 15-minute videos or less. So this video is part A of the two-part series where I'm going to talk about monster instantiation, NPC instantiation inside of the game. So I'll give a full overview of what I mean by those two components. So I'm just going to call them NPCs. So I've implemented monsters into the game where the engine recognizes them as entities that have health points, positions. They don't actually move around, but getting them to move around is now trivial. So that's kind of instantiating them into the game itself. And then the AI is actually generating, it's not AI in the sense of like AGI, like artificial general intelligence. I'm talking about like a very basic AI, like they'll run towards the player and like try to attack the player or whatever. So the AI is effectively responsible for determining how the monster actually moves around. So that's going to be another video. This is going to talk about monster instantiation, and the reason why this kind of ended up getting its own video is because I put a lot of time into it because I wanted to recycle a system that I already had in place called the player man system, the player manager. And what I ended up doing is, so on the server side, there's something called there was something called a player list, which is a big vector of a whole bunch of players that are currently in the game. And that has the player name, the player IP address, and some other fields about the player, health, that type of stuff. And what happens is you as a player, as you log in, you are added to the player list on the server side, and then your basically state is synchronized with all of the other players. And as you do things, you send your actions to the server updates the player on the player list, and then sends the new player back to all of the clients updating the state on that player. And what I did is, which is going to be super helpful for reducing a lot of code, is I just made monsters and players are effectively the same thing. So the player list is now called lifeform list, and this has, again, it's just a vector full of all of the players that live on the server side, but it also has all of the monsters. And what that does is now on the server side, I'm going to issue commands from another system, which I'm going to call the AI system, and those are going to follow the exact same path as they would if they were issued from a client over like a network. So that kind of disconnects, it does two things. It disconnects things nicely so that the AI system is its own standalone thing where I don't have to write additional code to modify monsters on the monster list. The manager just does that automatically. And it reduces the amount of additional code needed to actually synchronize the monsters in-game. So what that means is, instead of having a player manager and a monster manager, there's just one lifeform manager that manages all the life forms in the game, and the engine doesn't know the difference between a player and a monster. Effectively, they're the same thing. So any any functionality that I've implemented for a player, for example, collision, is just by default implemented for monsters, and attack, actions, and things like that. So that was kind of not really a breakthrough, but a good. I spent a little bit of time thinking about how I was going to architect it, and I settled on that. And I had to, of course, go back and refactor a bunch of code, which you always have to do when you want to implement changes, when you want to implement things like that. And the last thing that I want to talk about before we get into the code is how I actually implemented the monsters in the map. So I was originally going to make RON files, RON Rust object notation, and I would have like a list of all the monsters in each room, and then those monsters would link to another RON file, and then they would have I would build out a structure of where I wanted to put them, and I'm like, okay, well, that's just adding additional complexity that I don't really need. What I ideally want to do is go into Tiled, which is the map editor, which I covered in the last video, and I want to be able to just select monsters and just drop them down. So I've effectively chosen layer 7 for my monster layer, which will be where all the monsters are kept. That's what the engine is when the engine opens up a room, it's gonna look through that and find all the monsters. And these monsters, their attributes are given through the tiled application itself. So as I said in the last video, the map, meaning how everything is laid out, is called the TMX file, and the tile file, which is linked with the PNG, the sprite sheet, is called the TSX file. So if you go into, for instance, one monster here, I have all the different stances here, or all the different poses. You can add custom properties. So right here I have health point, name, skin, type. And effectively, all of the monsters just live on this layer 7. And then I will show, I'm going to go into my trusty Ranger application. And when the server boots up, the first thing it runs is this. Before it runs any of the systems, it's going to enter just this server state where I only have one state right now. But in the future, that will probably grow. And in here, I basically load in the TMX thing here. So when you create this, it's going to go and call this function called getMonsters, and that imports the map file for that room. And then inside of here, there's a function that you can call, that's part of the tiled library, called getTileSetByGID. So you effectively go through all of the tiles in that layer, and if there's any tiles there, since there's only the one layer is the monster layer, so if there's any tiles there, it's a monster. You grab the GID, which is the unique ID for that tile, and then you call this function called getTileSetByGID that returns a tile set, and then you can pull out the properties of that specific tile on that tile set. And what I mean by that is these properties here. No, not those properties there. These properties here. Health points, name, skin type, and then once you pull out those properties, those are just matched with this little outfits library here, where I've created a function called getOutfitFromString, where this string would be this ghost here. So this match statement would come down to ghost, and then this would return getOutfitGhost, and in here I have ghost, which is what this is doing, and this is going to return 331, and this is the different orientations for the sprites. So 331, 343, blah blah blah. So if you actually look at this, it should be like 331 343, 355. So that's like south, west, east, north. So that's how I know how to, once I have that object, I can orient the little guy however I want. Yeah, so effectively it pulls out all of the monsters from layer 7 and it throws them into a special structure called, that lives in here, called the monster structure, and it creates a vector of those. So there might be like 100 or like, however many per map. And then right after that, this is all server side. For maps and all the maps.list, because there might be like dozens of maps, and inside of those, each one of those maps, there might be dozens of monsters. So for all of those monsters and all of those maps, add those to the life form list, basically, which is the list on the server side. And then how the thing works is when you log in as a player, it's just going to send all of those to you. It's going to send you all those life forms. So let's see how that works. So I'm going to run cargo run release server. All right, cool. So there's a bug with it right now where it's not adding all of the monsters for some reason, but I will fix that. But the fundamentally, it's still the same as what I explained. So that's all we care about, the fundamentals. So it's implemented a ghost and a spider, and that's it. So thanks for watching. The next video I want to do on AI, like how I'm actually going to make these guys walk around and attack the player. So hopefully that one will be a bit more interesting. But anyways, thank you for watching.